Hello, I'm Sujata from CBSE, NEET, JEE Chemistry.in. In this video, we will learn how to apply the concept of the reactions of ethers with hydrogen iodide. You will see this question and its variations in many exams, and understanding this will give you a definite advantage. Explain the formation of the following products. You've been given two ethers, right? Now both are asymmetrical ethers. This is an aliphatic ether, and here you have an aryl group, benzene ring, aromatic ether. All right? Both these ethers are subjected to reaction with excess hydrogen iodide. A very interesting and an important reaction. The products depend upon the type of pathway followed. And the type of pathway followed depends upon the nature of the alkyl groups attached to the oxygen atom. Okay? In an asymmetrical aliphatic ether, if the alkyl groups attached to the oxygen are primary or secondary, in other words, if the likely carbocations produced are a methyl carbocation, a primary, and you have a cyclohexyl carbocation secondary, then the stability of carbocations is not what is focused. The SN2 pathway is what is focused. Alright? And in an SN2 pathway, the nucleophile iodide ion will get attracted to or will get attached to the less bulky alkyl group or at the less hindered site. So that bond will break. Okay, that bond will break, which is attached to a less bulky alkyl group. The iodide ion will get attached to the less bulky alkyl group, and the hydrogen will get bonded to the more bulky alkyl group, right? Or to the oxygen attached to the more bulky alkyl group. But since you have hydrogen iodide in excess, finally what happens is the OH attached to this cyclohexyl ring will also be replaced by iodide to give you this product. This was the situation for this specific question where you had an methyl and a cyclohexyl group. But suppose the oxygen in an ether is bonded to either a tertiary alkyl group, or a benzylic group, or an allylic group. Then the bond breaking will result in the formation of a highly stable tertiary carbocation or a benzylic or an allylic carbocation. So in the context of formation of these highly stable carbocations, SN2 pathway is not followed, SN1 pathway will be dominant. And the nucleophile will get attached to the more stable, the more bulky alkyl group, namely tertiary alkyl, benzylic or the allylic group. So the nature of the alkyl group attached to the oxygen of the ether will play a role in deciding what is the pathway followed. And different pathways, different SN pathways lead to different attachments of the nucleophiles. Alright? Now moving on to the next reaction, wherein you have an asymmetrical ether with an aromatic ring. It's an aryl ether, to be very specific, anisole or methoxybenzene. Despite taking hydrogen iodide in excess, you notice that the OH on the benzene ring is retained. It is not substituted by iodine. So let's get into the details of these two specific reactions. So here we have the first ether, methoxycyclohexane or methyl cyclohexyl ether, right? You have two lone pairs of electrons on the oxygen. You've got hydrogen iodide. The electrophile H+ will be attracted to the lone pair of electrons on the oxygen. One lone pair of electron on the oxygen, resulting in the formation of a protonated ether, which has a positive charge on the oxygen atom. In order to neutralize this positive charge and to restore the lone pair of electrons back to oxygen, either this CO bond or this CO bond has to break. Now this is a methyl group and this is a cyclohexyl group, not a tertiary benzylic or an allylic group, and therefore the pathway followed would be SN2 pathway. The pathway followed would be SN2 pathway, right? In which the nucleophile will be attached to the less bulky alkyl group, less sterically hindered alkyl group, right? As a result of which this bond will break and the iodide ion will attach itself to the CH3 group to produce methyl iodide, and the other product is cyclohexanol, where the lone pair of electron has been restored back to oxygen. In this reaction, we are using excess hydrogen iodide. In the presence of excess hydrogen iodide, this OH and this H will be lost as a molecule of water, right? And to this positive charge, as a result of which you have a positive charge on this carbon atom. The OH is lost as OH minus and H plus, water molecule is lost. The iodide ion will be attracted to this positive end to give you cyclohexyl iodide. That explains the formation of the products. So you have cyclohexyl iodide and methyl iodide as the products of this reaction. Okay? In the second reaction, we have an aromatic ring. It's an aryl ether, methoxybenzene or anisole. The first step is the same, wherein the protonation of the ether occurs. So you have a positive charge on this oxygen atom. In order to neutralize this positive charge, as I mentioned earlier, this CO bond or this CO bond has to break. Now this CO bond is very difficult to break because of the partial double bond character due to resonance. As a result of which this CO bond will not break. It is this CO bond which will break, resulting in the formation of phenol, and the iodide ion will be attracted to this carbon to give you methyl iodide. Further reaction with hydrogen iodide will not take place because further reaction would involve the OH to be substituted by iodine. Another nucleophilic substitution reaction is not possible because of the strength of the CO bond, difficult to break the CO bond, and due to the formation or presence of a bulky phenyl group, etc. You know that aromatic compounds substituted aromatic compounds do not undergo SN reactions readily. You need the presence of electron withdrawing groups on the ring for the OH to be substituted by a nucleophile, which is aromatic nucleophilic substitution reaction, which does not occur here, and therefore phenol does not undergo further reaction with hydrogen iodide. So these are the products of the reaction when methoxybenzene reacts with hydrogen iodide. We have over 230 videos with in-depth explanation of concepts in an easy and lucid manner in our organic chemistry course. Moreover, we have close to 400 videos of solutions to every kind of question that can be asked in any exam. Click the link in our description below to check out our course. Subscribe to our channel to regularly get new content to help you score high marks in chemistry.